Good morning. Welcome to Before Your Eyes Information Forum. We're looking at student scores. The body of the students is essentially 60 students by 9 subjects and 7 assignments. The data file looks as follows. As we normally do, we show the file, the size of the file and the relative data, and you can see the data has been normalized in this particular instance. We're able to as well have it sorted by the subject matter in normalized fashion and see what the data looks like. And from this, we're going to produce the visual images that relate to that. So essentially, let's start. What we're able to do right up front is create from the standardized data both the totality of the data, as you can see here over here, 60 students on the top right, and we can go down those since they're linked to the what we classify as the fingerprint per, in this case per student, of their total scoring. And as you can see, relative to the score, in some cases they have excelled, in some cases they have failed, or alternatively have been absent, as you can see clearly here, where the red touches the inner chamber, the score is null for non-appearance, and the rest of them are calibrated accordingly. Looking through this, we can get a collage of the different type of responses that have happened. And as you can see, it's accurate, but it leaves one searching for a better understanding of what really transpired. It's informative, but where's the answer? Before we carry on, the inner chamber is essentially the subtotal per module, and the above is essentially the score accordingly to the one through of those modules independently. So one is the average, the other is the actual module itself. From this, we're actually going to switch it a touch, and we're going to change the data so that it is hierarchically structured from best student to worst performing student, and we get the opportunity now to actually see the differentiation between the students in terms of their high scores and their low scores. Remember, this data has been normalized, so there is going to be below zero application because of the fact that normalization is at the mean, and everything below the mean is taken as a negative for illustration purposes. But we can clearly see the performing and non-performing students in the mid section of the bell curve through that. Interestingly is to look at this now that it's ordered, is to do the same as what we did prior and play it through the system, and you'll see that what was negative changes to mediocre, and from mediocre all the way to positive. So the outer boundary now is positive, indicating the qualitative nature of the student relative to the subject matters. And if we had to go further, there we're at 20, we're really starting to come into the zone of average student. You can see the increasing proportions of mid, and now we are at the negative side of the equation, so to speak, where the students are not performing at all well. We take that and we look at it now, the same data, and we're looking at it from the subject matters. So we can go to any subject. Let's just play it through. And we can now work out which subjects are causing the issue. We actually have got group totals. So we can look at the summary of the grouping of that subject assignments. And we have English, and obviously a subtotal right over here. There it is right there. And that's the subtotal of that, and any variation from that, so to speak, gives us an indication that becomes the bellwether for English, and that's the students relative to the bellwether. So there's this a vast difference between the averages and the actual student performance. Lastly, what we're going to do is take the same set of students, go through 1 through 60 version. Instead of it flipped, we're actually looking at the students. And we're looking at essentially the students through the index version of trying to appreciate what's going on. And these are the positive values. The exact opposite is true for the negative values, which are able to switch. Just flip with a flip. And there we have the inverted values of the negatives, which are now shown as positive, as just because they're inverted. And these are the um, the negative side of the students. The things that are in blue are actually absenteeisms, all very bad scores on the modules. Obviously, we can switch back, and now we're looking at those students once again, just like we look at gauges in a dashboard. We have an immediate view of what's going on, but there is a basis of data going through it. That would be seen as follows. For the entirety of the 9 subject matters, we can see what those 9 subject matters are. Select any of those 9 subjects, as you can see. Let's choose maths. And we come back to that 7 incline, and we're able to see how the students are performing accordingly. And that would be essentially at the maths level per student, what it looked like at that point in time. So with that said, we go into a pause period. Thank you for watching. I appreciate your time and giving us your time and effort. Hopefully, this is an indication of usage of student score as a way of presenting data in a totally different manner. Thank you.